Module 4.1, the Product and Quotient Rule. Objective 1, use the product rule to find derivatives. Objective 2, use the quotient rule to find derivatives. Objective 3, use the chain rule to find derivatives. Objective 4, use the product, quotient, and chain rules to solve real-world applications. Objective 1, using the product rule to find the derivatives. Though up to this point it has been easy for us to multiply functions first and then take the derivative, we will find in the near future that this is not always be practical. So in order to take the derivative of the product of two functions, we will use the product formula. Look at a few examples. Example 1, f of x is equal to 9x cubed times quantity x squared minus 6. If we're trying to find f prime of x, then we're going to need to take the first one, which is 9x cubed, times the derivative of the second one, which will be 2x, plus the derivative of the first one, which is 27x squared using the power rule, times the last one intact, x squared minus 6. So this would be equal to 18x to the fourth power plus, let's do a little distributive property here, 27x to the fourth minus 162 x squared. I look at combining my like terms, and so that would be equal to 45x to the fourth minus 162 x squared. And we have now found the derivative using the product rule. In example 2, we're dealing with a trinomial times a binomial. So let's find f prime of x. So we are going to take the first one, which is 5x to the fourth minus x plus 2 times the derivative of the second one, which is negative 5x to the fourth, plus, we're going to take the derivative of the first one, which is 20x to the third minus 1 times the second one intact, which is negative x to the fifth plus 5. In our second step, we're going to distribute this, so that would be negative 25x to the 8th plus 5x to the 5th minus 10x to the 4th plus, and now we're going to do FOIL on this one, so that would be 20 times negative, so it would be negative 20x to the 8th plus 100x cubed plus x to the 5th minus 5. And now we're going to go through and combine our like terms. Notice that we have a minus 25x to the 8th and a minus 20x to the 8th, so that would give us negative 45x to the 8th. Notice that we can combine this one with this one, so that would give us plus 6x to the 5th, and then we've got the minus 10x to the 4th plus 100x to the 3rd minus 5. And we have now used the product rule in order to find the derivative of two polynomials. Objective 2, use the quotient rule to find derivatives. Using the same logic we used in the introduction of the product rule, we will quickly find that rational functions are not going to nicely divide evenly so that we can find their derivatives. So we're going to find it much easier to take the derivative first using the quotient rule. The quotient rule uses the formula where you take the derivative of the first one times the second one intact minus the first one times the derivative of the second one all over the second one squared. Caution: we need to be very observant of where the rational functions are discontinuous. A rational function has restriction in the denominator, i.e. a point where the denominator will be equal to 0, then we are dealing with either an asymptote or a hole, which will cause the domain not to be continuous, in other words, discontinuity. Thus, a derivative cannot exist because a tangent line cannot be drawn from any endpoint. Let us look at a few examples of the quotient rule and always be cautious of any possibility of a discontinuity. In example 2, we are going to find the derivative of a rational function. So, f prime of x is going to be equal to, and we're going to let the top one be u and the bottom one be v. And my little formula for this is u prime v minus u v prime all over v squared. So if the top one, we're going to get 12x times the bottom one, which is x squared plus 4, minus the top one, which is 6x squared plus 7, times the derivative of the bottom one, which is 2x, all over x squared plus 4, which is the bottom one, quantity squared. Okay, let's go through and do a distributive property. That would be 12x cubed plus 48x minus, let's put that in brackets, 2x times 6x squared would be 12x cubed plus 14x all over the bottom one squared. So that would be equal to 12x cubed plus 48x minus 12x cubed minus 14x all over the bottom square. And then now I'm going to combine my like terms. And I've got 12x cubed and minus 12x cubed, so those cancel. And the 48 and the minus 14 will give me 34x over x squared plus 4 quantity squared. And we have now found the derivative using the quotient rule. In example 1, we're looking at f prime of x if f of x is equal to 2x squared plus 9 over 3x squared minus 5. Here we're going to let this be u and this be v, and remember that our formula is u prime v minus u v prime over v squared. So f prime of x will be equal to the derivative of the first one, which is 4x, times the second one, which is 3x squared minus 5, minus the first one, which is 2x squared plus 9, times the derivative of the bottom one, which is 6x, all over 3x squared minus 5, quantity squared. Distributive property, so we get 12x cubed minus 20x minus, we're going to bracket that off, and that'll give us 12x cubed plus 54x all over the denominator squared. Which will be equal to 12x cubed minus 20x minus 12x cubed by distributive minus 54x all over the denominator, quantity squared. Notice that the 12x's will cancel, which will give us negative 74x over 3x squared minus 5, quantity squared. And we have now found the derivative using the quotient rule. In example 2, if f of x is equal to 2x cubed over x squared minus 2, let's find the following. 1, we need to find where dx is discontinuous. We need to find dx, and then we need to find where dx is equal to 0. Our first part is to find where dx, or the derivative of f of x, is discontinuous. In order to do that, we need to look at the function and find out where there's restrictions in the domain. So we're looking at where x squared minus 2 cannot be equal to 0. I'll add 2 to both sides. So that gives me x squared can't be equal to 2. And we're going to take the square root of both sides. So x can't be equal to, and when you take the square root of an x squared, then you get plus or minus values because of the absolute value. So x cannot be equal to plus or minus 2. So these are 2 points and where they are discontinuous. Part B, we need to find d of x. Alright, so in order to take the derivative, we're going to let the top be u and the bottom be v. And we're going to remember that u prime v minus uv prime over v squared is how we take the derivative of using the quotient rule. So we would have this be equal to 6x squared, parenthesis, x squared minus 2 minus the top one, which is 2x cubed, times the derivative of the bottom one, which would be 2x, all over the bottom one squared, which is x squared minus 2 quantity squared. Again, doing our simplifying using distributive property, we would get 6x to the 4th minus 12x squared minus 4x to the 4th power, all over x squared minus 2 quantity squared. And then our last step would be to combine the like terms, so that would get 2x to the 4th minus 12x squared all over the denominator, which is x squared minus 2 quantity squared. And that is the derivative. Part C, we're going to find where d of x is equal to 0. So now that we got this derivative, in order for d of x to be equal to 0, we need the numerator to be equal to 0. In other words, if you have 0 over the denominator, then this is going to be equal to 0. And we need to keep track of our restrictions. Remember that x cannot be equal to plus or minus the square root of 2. So these can't be answers that would make it equal to 0. So what we're going to do is we're going to set the numerator, 2x to the 4th minus 12x squared equal to 0. We're going to factor out 2x squared out of both of them, and that will give us x squared minus 6 equal to 0. Well, we can set this one equal to 0, so 2x squared is equal to 0, so x would be equal to 0. So there is one place where the derivative is going to be equal to 0. And the next one, we can look at x squared minus 6 equal to 0. We can add 6 to both sides, and x squared would be equal to 6. Take the square root of both sides, so x would be equal to plus or minus the square root of 6. Now notice these three answers, 0, square root of 6, and negative square root of 6, are three answers in which where this derivative will be equal to 0, and they do not impede in the restriction. So these are our three answers. Objective 3. Use the chain rule to calculate the derivative. Many functions may actually be functions within functions. One must be able to find the derivative of these functions. These functions in the past have been called composite functions. If you are given a composite function, f of g of x, then the derivative of is the derivative of the outside with the inside intact times the derivative of the inside. It is easy to say that this is the derivative of the outside with the inside intact times the derivative of the inside. Let's take a look at a few examples of this. In example 1, we're going to find the derivative if the function of x is a composition of functions. F prime of x is going to be equal to the derivative of the outside, which would be 6 times the inside intact minus 1 from the exponent times the derivative of the inside, which will be 2x. And then we can put the 2x and the 6 together and get 12x times x squared plus 3 all to the 5th power. And we have now taken the derivative using the chain rule. In example 2, we're going to use several rules. If you'll look, we're going to be using the quotient rule, which is u prime v minus uv prime all over v squared. And we're going to let this be u and this be v. So let's start this. We got f prime of x is equal to, and we've got the derivative of the top one, which is 3 times 3x minus 2 to the second power times the bottom times the derivative of the inside, which is 3, times the bottom one, which is x squared plus 2 quantity squared, minus the top one, which is 3x minus 2 to the third power, times the derivative of the bottom one, which is 2 times x squared plus 2 using the chain rule, and that would be to the first power, times the derivative of the inside, which is 2x, all over the bottom one, which is x squared plus 2 quantity squared, and all of that squared. Okay, so my second step would be, let's put our 3's together, so that would be 9 times 3x minus 2 quantity squared times x squared plus 2 quantity squared minus 4x. We're going to put the 2x and the 2 together, and we've got 3x minus 2. We'll have 3 of those, and 1 of the x squared plus 2's, all over, and we've got x squared plus 2 to the fourth power, because power to power will multiply. All right, our next step, we're going to factor out 2 3x minus 2's from the top, and we're going to factor out 1 x squared plus 2 from the top. So that would give us 3x minus 2 squared times x squared plus 2 times, and then we're going to put back everything that's left, so the 9's left, and we've got 1 x squared plus 2 left, minus, we have a 4x. Notice that we should have a 3x minus 2 left, and the x squared plus 2 is gone because we took it out. All over x squared plus 2 to the fourth power. Okay, that'll be equal to, we've got 3x minus 2 quantity squared times x squared plus 2. And we're going to do our multiplying, so 9x squared plus 18 minus 12x squared plus 8x all over our denominator squared to the fourth power. And then we can combine our like terms, so that's going to give us 3x minus 2 squared times x squared plus 2 times, and we're going to put the x squareds together, so that'll give you minus 3x squared, and then we have plus 8x, and then we have plus the 18 all over x squared plus 2 to the fourth power. And now I want you to notice that we can cancel one of these with one of these 4. So our final answer here will be 3x minus 2 quantity squared times negative 3x squared plus 8x plus 18 all over x squared plus 2, and there will be 3 of them. And we have now done quotient rule with the chain rule involved in it. So this has had a lot of algebra in it. Objective 4. Use the product, quotient, and chain rules to solve real-world applications. Our example, the cost of producing chairs is C of x is equal to the square root of quantity 3x squared plus 400, where x is the number of chairs and Cx is the cost in dollars. Find the marginal cost for producing 20 chairs and interpret your answer. Our plan of action for this particular problem is we need to evaluate the derivative of C of x, and we need to evaluate it at 20 chairs. Okay, so the first thing we need to do is first let's find C of x, C prime of x, or the derivative of c of x? Well, to rewrite the square root of 3x squared plus 400, we would write it as 3x squared plus 400 equivalent to the 1/2 power. So now we're able to use the chain rule. So we're going to get 1/2 times 3x squared plus 400, and then we're going to subtract 1. So that would be 1/2 minus 2 over 2, which would be equal to 1/2 times 3x squared plus 400 to the negative 1/2. And if we wanted to simplify this, this would give us 1 over 2 times the square root of 3x squared plus 400. Okay, now that we've done this, we've got c prime of x. Now let's find it for 20 chairs. So we're going to do c prime of 20, which would be equal to 1 over 2 times the square root of 3 times 20 quantity squared plus 400, which would be equal to 1 over 2 times the square root of, and that would be 3 times 400 plus 400. And that would be equal to 1 over 2 times the square root of 1200 plus 400, which would be 1 over the 2 times the square root of 1600, and 1600 is 40 squared, so that would be 1 over 2 times 40, which is 1 over 80. This gives us the marginal cost of c of x after you have made 20 chairs.